Kia ora. I'm going to look at finding the distance between 2 points on a Cartesian plane. Now, if you haven't looked at coordinates yet, watch the previous video to do that, but if you're familiar with coordinates, then this is the next place for you. Okay, so finding the distance between 2 points. Now, if we've got 2 points, like for example A and B, the line segment which joins A and B is called AB. So if we want to find the distance between A and B, we write that like this. Distance AB equals. Okay, now the way that we're going to work this out is using the Pythagorean theorem. And that's because, if you remember from year 10 and year 11, Pythagoras came up with a way of finding the longest side, or finding any side, of a right-angled triangle. And if we look at this here, we actually have a right-angled triangle if we just draw in 2 lines there. So this is our right angle here. We just come down from A and across to B, or we can go up from B and across to A. But I'm going to do the first one. Either one will work because it will still use the same formula. So I've got my right angled triangle here, and we can use Pythagoras to work out any length of side, but we're going to look at the hypotenuse, which is the longest side. Now the Pythagorean theorem is this formula here, a squared plus b squared equals c squared, where a and b are your short sides and c is your longest side. Now if we want to get just c instead of c squared, we're going to square root everything to get this formula here. So in this case, since c is our hypotenuse, we can find this length c by using this formula here, where we put in the length of A and the length of B. Square them both, add them, and then take the square root. So the length of A and B is the height. Well, it's a little bit confusing with our capital A and capital B, but this little a and little b, we can put them in any order, but I'm going to make this one A and this one B. You can put them the other way around so that this side is A and this side is B. It doesn't matter because we're still going to add them and square them and add them, so it doesn't matter which way around we do them. So if this is A here, the length of A is 3. And the length of B is 1, 2, 3, 4, 5, 6. So I have the lengths of A and B just by counting how many I've gone along and how many I've gone up between A and B. So that is, if we're trying to find the distance of AB, the distance of AB is the same as C because we've said that this C is our longest side. So the distance between those two is the length of C. So now I just need to put these lengths into that formula and then work out the answer. So that's 3 squared plus 6 squared. Now because this is under a square root, this means that this would have to be done first before we square root. And we'd have to, and because according to BEDMAS, we have to do our powers first before we do the addition. So to work out the next step, I'm going to leave my square root there because we're not going to use it yet. We're going to do it later. And I'm going to take that 3 squared and that 6 squared. So 3 squared is 9, and I leave my plus sign, and the 6 squared is 36. So that gives me 9 plus 36. The next step, I'm still not up to doing my square root yet. I still have to do the brackets first. So I have to add the 9 plus 36 before I can square root. So 9 plus 36 is 45. And now I have to take the square root of 45 to find my distance. So I'm just going to bring up a calculator for that. And that is, I keep forgetting where I put this. I'm going to take the square root of 45. 6.7. I'm just going to round it to one decimal place. So that is 6.7. Actually, let's round it to 2. Let's round it to 2 decimal places. So I'll do 6.71. And I've rounded it to 2 decimal places, so I'm going to write 2 dp. And that's how you find your distance. Now that might look really complicated to begin with, but if you practice it a few times, then it'll get easier. So now that we've done the distance between those two, let's try the next two. So I'll erase this so it's not as confusing. Right, we found the lengths A and B. Let's do length between A and D. So that there is going to be distance AD, or length AD. Either one's fine. Now, this formula might be written a little differently. You might have a formula that says distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. That might be your equation there. But you still work it out the same way, because what the x1 and the x2 is what the x coordinate of this one versus this one is. And you can see if you subtract those two, you get the distance between those, which happens to be that length along there. So it's still the length along here, and then, so that's the distance there, that becomes A. And then this part is where it is on the y-axis for both of them. So you can see they're both going like this. And since it's subtracting, it's looking at the difference between those two, which is that length there. And that length gives us that side of the triangle. So our x1 minus x2 gives us this side of the triangle, the distance between those two x coordinates. And the y1 minus y2 gives you the distance between the two y coordinates, which gives you that distance there, which is the same thing that we used in this formula here with the two short sides of the triangle. In this case, we're trying to find this side here. That's our longest side. That's C. So the formulas work the same way. Right, so distance AD, we want the length, the base of our triangle and the height of our triangle as A and B. So that distance there is going to be the difference between the two x values. That's 3. And that has to be squared. And the distance between the two y values, the length between the two y values, is 6 again. So that gives us the square root of 3 squared plus 6 squared. Remember, we have to do the powers first, and then we add, and then we square root. So 3 squared is 9, plus 6 squared is 36. So that gives us 45 when we add those together, and then we square root that. And because we had the same thing here, we're going to get the same square root of 45 here as here. We're going to get the same answer when we square root it, which is going to give us 6.71 with 2 decimal places. Alright, let's try the distances. Let's try the distance between A and C. So I'll get rid of these little lines here. let's do this distance here. So we've done two formulae. We've got, actually I'll get rid of this first. We've got distance equals the square root of those two differences. And then we've got this one here. Either one will work. Now we've worked out those two distances between A and B and A and D. So let's do this one here between A and C. So distance AC, and of course you can do this for any pair, so you could do B and C or B and D or B and C, B and D or C and D, but for some reason I've just ended up working with A's, but that's fine. So distance AC equals the square root of the two lengths of the two sides of the triangle. So let's put those in. So we've got the height of the triangle and the width of the triangle. Now let's do the width first. So my width along here is 3, so that's 3 squared in my formula, because I just have to replace A with 3 and the squared still stays there. And my height is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So plus 9, and then we leave that squared there. Now we'd have to do the brackets first, and inside the brackets we have to do the powers first and then the addition. So 3 squared is 9, 9 squared is 81, 9 plus 81 is 90, and that equals square root of 90 is 9.49, rounded to 2 decimal places. Of course, if these x and y axes are done in centimetres, it will be 9.49 centimetres. If they're done in metres, you do 9.49 metres, and yeah, and so on, if it's measured in different things. But yeah, that's how you find the distance between 2 points. Thank you for watching. Hopefully that helps. Good luck with the activities that your teacher sets or that you find on the Google Classroom. Thanks for watching.